Picture this. You're floating in an endless void, a cosmic canvas so vast it defies comprehension. No stars, no galaxies. Just a seething cauldron of energy where space and time are still figuring themselves out. This is the universe at its infancy, moments after the Big Bang, some 13.8 billion years ago. You're witnessing the raw, untamed birth of everything. Every atom, every star, every dream you've ever had about the cosmos. It's chaotic, it's beautiful, and it's where our journey to find the first cosmic civilization begins. Could something as complex as a civilization have emerged in this fiery crucible? Let's dive in. The Big Bang wasn't an explosion in space. It was the expansion of space itself. Imagine a balloon inflating, but instead of air, it's filled with the raw ingredients of reality: quarks, gluons, and a whole lot of heat. In those first fractions of a second, the universe was hotter than 1,000,000 suns, denser than a neutron star, and smaller than a grain of sand. You'd think nothing could survive this, right? But here's the kicker. The seeds for life, and maybe even civilizations, might have been planted far earlier than we've ever dared to imagine. Let's rewind to those first moments. The universe cools rapidly, and within a minute, protons and neutrons start sticking together, forming the nuclei of hydrogen and helium, the building blocks of stars. By 380,000 years, the universe has cooled enough for atoms to form, letting light break free. This is the cosmic microwave background, the faint glow you can still detect today with sensitive telescopes. It's like the universe's baby picture, and you're holding it in your hands. But here's where things get wild. Within 1 billion years, the first stars and galaxies start to form. That's a blink in cosmic time. Could life, intelligent life, have gotten a head start in this primordial soup? Now, you might be thinking, life, already? That's like expecting a cake to bake before the oven's even preheated. Fair point, but hear me out. The early universe wasn't just a chaotic mess. It was a chemical playground. Those first stars, called population 3 stars, were massive, burning hot and fast, forging heavier elements like carbon, oxygen, and nitrogen in their cores. When they exploded as supernovae, they scattered these elements across space, creating the raw materials for planets and, potentially, life. By the time the universe was just a few 100 million years old, it had the ingredients for rocky planets. If planets formed, could life have been far behind? Let's talk conditions. Life, as we know it, needs a few things: liquid water, organic molecules, and a stable environment. In the early universe, things were rough. Radiation was intense, and stars were exploding left and right. But some corners of the cosmos might have been surprisingly cozy. Imagine a planet orbiting a stable, second-generation star in a young galaxy. This planet could have had liquid water, maybe even oceans, warmed by geothermal heat or a nearby star's glow. You're standing on its surface, feeling the warmth of volcanic vents under your feet, gazing at a sky lit by newborn stars. It's not Earth, but it's not impossible either. Here's a fun fact. The oldest known star, HD 140283, nicknamed Methuselah, is 14.5 billion years old. Older than the universe itself, which is a bit of a cosmic head-scratcher. Scientists think it formed just a few 100 million years after the Big Bang. If stars like this could form so early, why not planets? Why not life? And here's something weirder. Some models suggest that the early universe might have had habitable zones around supermassive black holes, where radiation from infalling matter could have warmed nearby planets just right. Sounds like science fiction. but it's a real hypothesis. Now, let's stir the pot with a bit of academic debate. How early could intelligent life have formed? Some scientists argue it took Earth 4.5 billion years to produce us. So the early universe was too young for anything complex. Others say the rapid formation of heavy elements and planets means life could have started as early as 10 billion years ago. That's billions of years before Earth even existed. Imagine a civilization rising when the universe was still a teenager, building cities while our planet was just a twinkle in the cosmos's eye. Let's paint a picture. You're on one of these ancient worlds, standing on a rocky shore under a sky blazing with stars so close they feel like you could touch them. The air hums with strange energy, maybe from a nearby quasar bathing the planet in light. This isn't just a planet. It's a cradle for something extraordinary. Could a species here have looked up, like you're doing now, and started asking the same questions we do? Did they build telescopes, launch probes, or even leave their planet behind? Historically, we've always assumed life needs billions of years to evolve, thanks to Earth's timeline. Charles Darwin's theory of evolution, published in 1859, showed how gradual changes over eons led to complex life. But what if the early universe was a pressure cooker, speeding things up? Maybe evolution on these worlds worked differently, driven by intense radiation or unique chemistry. It's a stretch, but not impossible. After all, the universe loves to surprise us. Just look at extremophiles on Earth, thriving in boiling vents or frozen ice. If bacteria can handle that, who's to say an alien species couldn't handle a young, wild cosmos? Here's a quirky detail. The early universe was so dense that sound waves could travel through it, creating baryon acoustic oscillations. These ripples shape the distribution of galaxies we see today. Imagine an ancient civilization hearing the universe hum, like a cosmic lullaby, as they built their first cities. It's a poetic thought, isn't it? Their myths might have been woven from the vibrations of creation itself. As you stand in this primordial universe, you can't help but feel small, yet connected. Every atom in your body was forged in those early stars. You're not just observing this story, you're part of it. But here's the big question. If a civilization did rise back then, what would they have left behind? Could their legacy still be out there, waiting for us to find it? That's where we're headed next. But before we go, let's hear from you. What do you think a civilization this early would look like? Drop your thoughts in the comments, and let's keep this cosmic journey going. You're drifting through a young galaxy, a swirling chaos of gas and newborn stars, each one a fiery furnace spitting out the elements of creation. The universe is barely 1 billion years old, yet it's already bustling with potential. The air, or whatever passes for it here, crackles with energy, and you can almost feel the cosmic chemistry at work, stitching together the first molecules that might, just might, spark life. Could these early galaxies, still glowing from their birth, have cradled the first seeds of life? Let's explore the wild possibility that the universe didn't wait long to get the party started. Picture the scene. A star-forming nebula, a glowing cloud of gas and dust stretching light years across. It's like a cosmic nursery where massive stars are born, live fast, and die young in spectacular supernovae. These explosions scatter carbon, oxygen, and nitrogen, the Lego bricks of life, into the void. You're watching one of these stars go supernova, a blinding flash that lights up the galaxy like a cosmic firework. The shock waves ripple outward, compressing gas clouds and triggering the formation of new stars and planets. Somewhere in this chaos, a rocky world takes shape. Could it be the first home for life? Now, let's get to the nitty-gritty. For life to emerge, you need a few key ingredients: organic molecules, liquid water, and a stable environment. In the early universe, things were intense. Radiation bathed everything, and stars were more like cosmic blowtorches than gentle suns. But don't count it out yet. Some of these young planets might have had just the right conditions. Imagine a world orbiting a stable, second-generation star, its surface warmed by volcanic activity or tidal forces, with pools of liquid water glinting under a sky ablaze with stars. You're standing there, feeling the ground hum with geothermal heat, smelling the faint tang of sulfur in the air. It's not exactly a beach vacation, but it's a place where life could take root. Here's a little cosmic humor for you. If aliens existed back then, they probably didn't have to worry about sunscreen. Radiation was their bigger problem. But seriously, the chemistry of life isn't as fussy as you might think. On Earth, we've found organic molecules in meteorites, and scientists have recreated simple amino acids in lab experiments mimicking early cosmic conditions. The famous Miller-Urey experiment in 1953 showed that zapping a mix of gases with electricity, mimicking lightning or radiation, can produce the building blocks of life. If it happened here, why not out there, billions of years earlier? Let's talk about those conditions in more detail. The early universe was a chemical playground. Those massive population 3 stars we mentioned, they burned so hot they fused elements faster than a chef whipping up a 5-course meal. When they exploded, they seeded space with carbon, nitrogen, and oxygen. By the time the universe was 500 million years old, these elements were mixing in gas clouds, forming complex molecules. Some of these molecules, like polycyclic aromatic hydrocarbons, are surprisingly resilient, floating around in space like cosmic confetti. You can almost see them now, glinting in the starlight, ready to land on a planet and start something big. But here's the quirky bit. The early universe might have been a better place for life than we think. Some scientists suggest that the high metallicity, fancy term for the presence of heavier elements, in young galaxies could have sped up planet formation. Rocky planets need elements like silicon and iron, and those were already abundant by the time the universe was 1 billion years old. Plus, some of these early stars formed in dense clusters, creating stable environments where planets could orbit without getting blasted by radiation. Imagine a planet tucked away in a cozy corner of a galaxy, shielded by a thick atmosphere, its surface bubbling with chemical reactions. You're walking across it, your boots crunching on alien soil, wondering if something's already crawling in the shadows. Now, let's stir up some academic debate. How fast could life have evolved in these conditions? On Earth, it took about 1 billion years after formation for single-celled organisms to appear, and another 3 billion for complex life. But the early universe was a pressure cooker: higher densities, more intense radiation, and faster chemical reactions. Some researchers argue that life could have emerged in just a few 100 million years, under the right conditions. Others say complex life needs time to simmer, like a good stew. Could an intelligent species have evolved when the universe was still in its toddler years? It's a question that keeps astrobiologists up at night. Historically, we've leaned on Earth's timeline to guess when life could arise. The discovery of 3.8 billion-year-old microbial fossils in Greenland's rocks tells us life got going fast here. But what if other worlds had a head start? Imagine a species developing technology while Earth was still a molten ball of lava. Their cities might have risen under skies lit by quasars, their telescopes scanning a universe still brimming with raw energy. You're standing in one of those cities now, surrounded by alien architecture, feeling the weight of a civilization that might have come and gone before we ever existed. Here's a weird detail to chew on. Some early galaxies were so compact that their stars were packed closer together than in our Milky Way. This could have made interstellar travel easier for an advanced species. Instead of light years between stars, they might have been hopping between worlds just a few light days apart. Imagine their version of a road trip, zipping from one planet to another, trading ideas, or maybe arguing over who gets the best parking orbit. As you float through this young galaxy, you can't help but feel the buzz of possibility. Every star, every planet, is a potential cradle for life. The universe was young, but it wasn't barren. It was alive with potential, ready to spark something extraordinary. If life did emerge this early, what kind of creatures would it produce? Would they be like us, staring up at the stars, or something so alien we can't even imagine? And if they built a civilization, what traces might they have left behind? That's what we'll chase next. But first, let's hear from you. How early do you think life could have started in the universe? Drop your thoughts in the comments, and let's keep unraveling this cosmic mystery together. You're standing on the edge of a cosmic cliff, staring into the vastness of a universe that's been around for billions of years. The stars above you burn with secrets, and you can't shake the feeling that someone or something was here long before us. What if a civilization rose to unimaginable heights when the universe was still young, leaving behind clues woven into the fabric of space itself? This is the heart of the Oracle hypothesis, a bold idea that a super-advanced civilization, the Oracles, once thrived and shaped the cosmos in ways we're only beginning to understand. Buckle up, because we're about to chase their ghostly trail. Imagine a civilization so advanced, it makes our tech look like cave paintings. The Oracles, as we'll call them, didn't just survive in the early universe. They dominated it. Picture their cities sprawling across planets, their ships weaving between stars, their minds grappling with the same questions we ask today. Why are we here? What's out there? The Oracle hypothesis suggests they existed billions of years ago, perhaps when the universe was just a couple billion years old, and reached a level of sophistication that allowed them to leave a lasting mark. You're floating above one of their worlds now, watching towers of alien metal gleam under a sky lit by a nearby quasar. It's awe-inspiring, but also a little eerie. Where did they go? Let's break this down. The Oracle hypothesis isn't just sci-fi daydreaming. It's a thought experiment grounded in astrobiology and cosmology. If life could form early, as we explored last time, then intelligent life could have followed. The universe was smaller and denser back then, meaning stars and planets were closer together. This could have made it easier for a civilization to spread across a galaxy, like neighbors popping over for a cosmic coffee. Their technology might have harnessed the raw energy of stars or even black holes, bending the laws of physics in ways we can barely dream of. You're picturing it now. A Dyson sphere encircling a star, soaking up every drop of its energy, or maybe a network of wormholes linking distant worlds. Here's a bit of cosmic humor to lighten the mood. If the Oracles had social media, their status updates would probably be, "Just built another megastructure, NBD." But seriously, what makes this hypothesis so compelling is the math. The universe is 13.8 billion years old, and Earth's life took 4.5 billion years to produce us. If a planet formed just 1 billion years after the Big Bang, it could have had a 9 billion year head start on us. That's enough time to evolve, build, and maybe even vanish before our sun was even a twinkle in the cosmic eye. You're starting to feel the weight of that timeline, aren't you? It's like realizing your ancestors might have been outdone by someone else's ancestors eons ago. Now, let's talk evidence, or the lack of it. The Oracle hypothesis hinges on the idea that such a civilization would leave traces. But what would those look like? Maybe they built megastructures, like giant rings or artificial planets, still orbiting forgotten stars. Maybe they sent out signals, now faded into the cosmic background noise. You're scanning the sky with an imaginary telescope, searching for a flicker of something unnatural, a pattern, a pulse, a hint that someone was out there. In 1960, astronomer Frank Drake kicked off the search for extraterrestrial intelligence, SETI, aiming to detect alien signals. So far, we've heard nothing. But the Oracle hypothesis suggests we might be looking in the wrong places or the wrong times. Here's a quirky detail. Some scientists propose that advanced civilizations could have left messages in the cosmic microwave background, the universe's oldest light. Imagine etching a signal into the afterglow of the Big Bang. Like cosmic graffiti that says, "We were here." It sounds wild, but researchers have actually studied whether artificial patterns could persist in that radiation. So far, no luck. But the idea that someone might have tried is enough to make your skin tingle with possibility. Now, let's dive into the academic debate. Could a civilization really reach such heights so early? Some argue the early universe was too chaotic, too much radiation, too many supernovae for complex life to thrive. Others counter that the density of early galaxies made interstellar travel easier, giving a civilization the chance to spread fast. Imagine the oracles colonizing a galaxy when Earth's building blocks were still just cosmic dust. The debate gets heated. If they existed, why haven't we found their ruins? Or did they transcend physical form, becoming something we can't even comprehend? You're standing in their hypothetical shoes, wondering if they solved the mysteries we're still chasing. Picture their world in more detail. You're walking through an alien city, its structures pulsing with energy, maybe powered by miniature black holes or zero-point energy. The air hums with the faint buzz of machinery, and the sky above is a tapestry of stars so close they feel like a ceiling. Their culture might have been as diverse as ours, with art, music, and philosophy shaped by a universe still in its youth. Did they worship the stars, fear the black holes, or dream of crossing the galaxy? You can almost hear their voices, carried on a wind that's long since faded. Historically, humans have always looked to the past for clues about our origins. The discovery of ancient Sumerian tablets, dating back to 3000 BCE, showed us how early humans built complex societies. If we could do that in a few thousand years, what could the oracles have done in billions? Their technology might have been so advanced it's invisible to us, like trying to spot a smartphone in a cave painting. Maybe their legacy is in the stars themselves, arranged in patterns we haven't yet recognized. As you float through this ancient galaxy, you feel a mix of awe and humility. The oracles, if they existed, were the trailblazers of the cosmos, the first to ask the big questions. But their story raises another. What happened to them? Did they survive, evolve, or vanish? And if they left clues, where should we look? That's where we're headed next. But before we go, let's hear from you. What kind of civilization do you think the oracles might have been? Drop your ideas in the comments, and let's keep chasing their shadow across the stars. You're soaring through a galaxy billions of years old, your eyes scanning the cosmos for a whisper of something extraordinary. The stars around you pulse with light, each one a potential keeper of secrets from a civilization long gone. The Oracle hypothesis has you hooked. If an ancient, super-advanced civilization, the oracles, once ruled the early universe, they must have left something behind. But what does a cosmic calling card look like? Are there megastructures, signals, or anomalies hidden in the starlight, waiting for you to find them? Let's hunt for the traces of the first cosmic civilization. Imagine you're an interstellar detective, your telescope a magnifying glass pointed at the universe. The oracles, if they existed, weren't just building campfires. They were likely crafting feats of engineering that could outshine entire galaxies. Their legacy might be etched in the cosmos, but it's not like they left a neon sign saying, "We were here." You're sifting through starlight, looking for patterns that don't belong. Maybe a star that blinks too regularly, a galaxy that's shaped too perfectly, or a signal that hums with purpose. The universe is a big place, and finding their fingerprints is like searching for a needle in a haystack the size of infinity. Let's start with megastructures. The oracles could have built Dyson spheres, massive shells or swarms of satellites encircling stars to capture their energy. Picture yourself orbiting a star wrapped in a glittering lattice, its light dimmed as the structure soaks up every photon. In 1964, physicist Freeman Dyson proposed this idea, inspired by the thought that advanced civilizations would need vast amounts of energy. If the oracles built these, we might spot them as stars that flicker unnaturally or emit unusual infrared signatures. You're staring at one now. Its silhouette a perfect sphere against the cosmic backdrop. And you can't help but wonder, is this natural? Or did someone make it? Now, let's talk signals. The oracles might have sent out radio waves, lasers, or even gravitational pulses to announce their presence. You're tuning your cosmic radio, listening for a pattern that stands out against the universe's static. In 1977, astronomer Jerry Amon detected the famous "wow" signal, a 72-second burst of radio waves that never repeated. It's one of the most tantalizing hints we've ever found. But was it the oracles? Probably not. They'd likely be more subtle. Their signals faded over billions of years. Still, you're holding your breath, hoping for a beep that says, "You're not alone." Here's a cosmic chuckle. If the oracles sent us a message, it's probably stuck in the universe's spam folder, lost among a trillion natural signals. But in all seriousness, searching for these traces is tricky. The universe is old, and time erases even the grandest monuments. A megastructure might have crumbled into dust, or a signal might have weakened to a whisper. Yet, some clues could persist. Imagine a planet with unnatural isotopes in its atmosphere, a leftover from alien industry, or a star system arranged in a geometric pattern, like a cosmic Stonehenge. You're flying past such a system now, its planets aligned too perfectly to be chance. And your heart races with the thought, this could be it. Let's dive into a quirky possibility. What if the oracles left their mark in the cosmic microwave background, CMB? This faint glow, the universe's oldest light, carries patterns from the Big Bang. Some wild theories suggest an advanced civilization could have tweaked it, embedding a message in the CMB's temperature fluctuations. It's like writing, "We were here," in the universe's DNA. Scientists have looked for such anomalies, but so far, it's just noise. Still, the idea that someone might have tried makes you feel like you're part of a cosmic treasure hunt. Now, let's spark some academic debate. How do we distinguish an alien artifact from a natural phenomenon? Some argue that anything too orderly, like a perfectly spherical star or a repeating signal, screams artificiality. Others say the universe is full of weird, natural patterns, like pulsars that mimic radio beacons. Imagine the oracles built a galaxy-sized structure, only for us to mistake it for a quirk of gravity. You're wrestling with this now, wondering if that oddly dim star is a Dyson sphere or just a dust cloud playing tricks. The debate rages on. Are we missing the obvious? Or is the universe just that good at fooling us? Picture yourself closer to one of these clues. You're orbiting a star that's behaving strangely. Its light dips in a rhythmic pattern, like a cosmic Morse code. Data from the Kepler Space Telescope, launched in 2009, has shown stars like KIC 846285, aka Tabby Star, with bizarre dimming patterns. Some speculated it could be a megastructure, though dust is the likely culprit. Still, you're imagining the oracle's handiwork. A swarm of solar panels orbiting in perfect sync, casting shadows we can see from Earth. The air, or lack thereof, feels electric with possibility, and you can almost taste the discovery. Here's a historical nod. Humanity's search for alien life kicked off in earnest with the Arecibo message in 1974, a radio signal we sent toward the M13 star cluster. It was our attempt to say, "Hey, we're here." If the oracles did something similar, their signal could be out there, stretched and faded by billions of years of cosmic expansion. You're listening for it, your ears straining for a note that's been traveling since the universe was young. As you drift through this galaxy, you feel the weight of the search. Every star, every planet, could hold a clue. But the universe is vast, and time is a relentless eraser. The oracle's legacy might be right in front of you, hidden in plain sight, or it might be gone forever. But the hunt itself is thrilling. It's a testament to your curiosity, to humanity's drive to find answers. What would their technology look like, and how would it change our view of the cosmos? That's where we're headed next. But first, let's hear from you. What kind of cosmic clue would convince you the oracles existed? Drop your thoughts in the comments, and let's keep searching the stars together. You're hovering above a planet that defies everything you know about reality. Its surface glows with intricate patterns of light, not from cities, but from structures so vast they reshape the horizon. This is the work of the oracles, the hypothetical ancient civilization that might have ruled the cosmos billions of years ago. If they existed, their technology wasn't just advanced, it was godlike, capable of bending stars, sculpting planets, and maybe even rewriting the laws of physics. You're about to step into their world, where imagination meets the edge of possibility. What could the oracles have built? And how would their tech redefine what we think is possible? Picture a star system transformed into a cosmic machine. You're gazing at a star wrapped in a shimmering Dyson swarm, countless orbiting panels drinking in every photon, powering a civilization that spans light years. The oracles didn't stop at solar panels. They might have harnessed black holes, spinning them to extract energy like a cosmic battery. You feel the hum of their machines in your bones, a vibration that seems to sync with the pulse of the universe itself. This isn't science fiction. It's the logical endpoint of a civilization that had billions of years to innovate before Earth was even a speck of dust. Let's break down what this tech might look like. The oracles could have built megastructures on a scale that makes our skyscrapers look like sandcastles. Imagine a ring world, a massive band encircling a star. Its inner surface a sprawling habitat for trillions of beings. You're walking on it now, the ground stretching endlessly in all directions, the star above casting a warm, eternal day. Or picture a matryoshka brain, a series of nested Dyson spheres, each layer a supercomputer processing more calculations than every computer on Earth combined. The air around you crackles with data, as if the planet itself is thinking. Here's a cosmic giggle. If the oracles had traffic jams, they were probably caused by starships queuing up at wormhole toll booths. But in all seriousness, their tech would likely exploit physics we're only beginning to understand. Take zero-point energy, tapping into the quantum fluctuations of empty space. Or consider wormholes, shortcuts through space-time that could link distant galaxies. You're standing at the mouth of one now, its edges shimmering like a liquid mirror, promising a journey to a star system billions of light years away. The oracles might have used these to knit their empire together, making the universe feel as small as a neighborhood. Let's ground this in some history. In 1965, Soviet astronomer Nikolai Kardashev proposed the Kardashev scale, a way to rank civilizations by their energy use. A Type 1 civilization uses all the energy of its planet, Type 2 harnesses its star, and Type 3 commands an entire galaxy. The oracles? They'd likely be Type 2 or beyond. Maybe even Type 4, manipulating the universe itself. You're imagining their power now, redirecting supernovae, stabilizing stars, or even creating artificial planets from scratch. Their engineering would make our moon landings look like a toddler's first steps. Now, here's a quirky detail. Some scientists think an advanced civilization could use black holes as computers. By feeding matter into a black hole in precise patterns, they could encode information in its radiation. Imagine the oracles using a black hole as their version of a hard drive, storing the knowledge of 1 billion years in a singularity. You're peering into its event horizon, seeing faint flickers of encoded data, and it feels like staring into the mind of a god. Let's spark an academic debate. Could a civilization achieve such feats without destroying itself? Some argue that mastering this kind of tech requires not just brains, but stability, social, environmental, and cosmic. Others say the sheer scale of these projects would invite catastrophe, like accidentally triggering a supernova while building a Dyson sphere. You're weighing this now, wondering if the oracle's ambition outpaced their wisdom. Could they have built a galaxy-spanning empire only to collapse under its own weight? Or did they transcend, becoming something beyond matter and energy? Picture their daily life, or whatever passed for it. You're in one of their habitats, a floating city in orbit around a neutron star. The walls pulse with energy, adapting to your presence like a living thing. Their technology might have blurred the line between biology and machine, with nanobots repairing bodies or minds linked directly to their networks. You touch a console, and it responds, projecting holographic star maps that show their empire's reach. The air smells faintly metallic, charged with the energy of a civilization that tamed the cosmos. Did they live like us, with hopes and fears? Or were they so advanced they left emotion behind? Here's another angle. Their tech might not just be physical. The oracles could have mastered consciousness, uploading their minds into artificial substrates, or even dispersing themselves across the universe as pure information. You're imagining them now, not as beings, but as a network of thought, flowing through the galaxy like a cosmic internet. This raises a wild possibility. What if their tech is still active, running silently in the background of the universe, waiting for us to notice? As you explore this alien landscape, you feel a mix of awe and unease. The oracle's technology could have reshaped entire galaxies, but it also makes you wonder about our own future. If we ever reach their level, will we build wonders or court disaster? Their legacy, if it exists, might be a blueprint or a warning. What's the next step in finding their traces? That's where we're headed. But first, let's hear from you. What kind of technology do you think the oracles might have built? Drop your wildest ideas in the comments, and let's keep dreaming of their cosmic achievements. You're floating in the vast emptiness of space, surrounded by 1 billion twinkling stars, each one a potential home for life. The universe feels alive, buzzing with possibility, yet it's eerily silent. If the oracles, that ancient civilization from our hypothesis, once ruled the cosmos with their godlike technology, where are they now? Why does the universe seem so quiet, despite its age and size? This is the Fermi paradox, the cosmic riddle that asks, if intelligent life is out there, why haven't we heard from anyone? Let's dive into this mystery and see if the oracles hold the key to unlocking it. Picture yourself in a galactic control room, monitors glowing with data from every corner of the cosmos. You're scanning for signals, structures, anything that screams civilization. But all you get is static, the universe's equivalent of a dial tone. The Fermi paradox, named after physicist Enrico Fermi in 1950, points out the contradiction between the high probability of alien life and the total lack of evidence for it. The oracles, if they existed, should have left a mark. Megastructures, radio waves, or even a cosmic hello. So why does it feel like you're shouting into a void? Let's unpack this. The universe is 13.8 billion years old, with billions of stars in every galaxy and billions of galaxies in the observable universe. Even if only a tiny fraction of planets host life, the numbers suggest there should be countless civilizations out there. The oracles could have been the first, spreading across galaxies when the universe was young. You're imagining their empire now. Starships zipping between worlds, Dyson spheres glowing like cosmic lanterns. Yet, when we point our telescopes at the sky, we see nothing. No signals, no megastructures, just the hum of natural processes. It's like the universe is ghosting us. Here's a bit of cosmic humor. Maybe the oracles are out there, but they're just bad at answering their cosmic texts. In all seriousness, the Fermi paradox forces us to grapple with some big ideas. One possibility is that intelligent life is rare. Maybe the oracles were a fluke, the only ones to rise so early. Another is that civilizations don't last long, collapsing under their own weight before they can spread. You're picturing the oracles now, their cities crumbling, their signals fading, leaving the universe silent once more. Or maybe they're still out there, but their tech is so advanced we can't even detect it, like trying to spot a stealth jet with a magnifying glass. Let's explore some explanations tied to the oracles. First, the Great Filter hypothesis suggests there's a barrier that stops most civilizations from reaching galactic dominance. Maybe the oracles hit this wall. Perhaps their tech triggered a catastrophe, like a runaway black hole or an ecological collapse. You're standing on one of their ruined worlds, the air heavy with the dust of a fallen empire, wondering what went wrong. Alternatively, they might have transcended, becoming beings of pure energy or consciousness, invisible to our primitive instruments. You're straining to sense them, feeling a faint tingle, as if their essence lingers in the cosmic background. Here's a quirky detail. Some scientists suggest advanced civilizations might hide their presence deliberately, a concept called the zoo hypothesis. Imagine the oracles watching us like we watch ants, keeping their distance to avoid interfering. You're looking up at the stars, wondering if they're out there, studying humanity like a cosmic reality show. It's a wild idea, but it explains why we haven't seen their megastructures or heard their signals. They're intentionally staying off our radar. Now, let's stir up some academic debate. Is the Fermi paradox evidence that intelligent life is doomed? Or are we just looking in the wrong places? Some argue that life is common but short-lived, snuffed out by war, climate collapse, or cosmic disasters like gamma-ray bursts. Others say we're missing the oracle's signals because we're stuck thinking in human terms, radio waves and visible structures. What if they communicate with gravitational waves or quantum entanglement? You're wrestling with this now, wondering if our tech is too primitive to catch their vibe, like trying to tune into Wi-Fi with a telegraph. Picture the scene more vividly. You're aboard a futuristic observatory, floating in deep space. your screens filled with data from distant galaxies. The stars outside glow with a cold, indifferent light. But you're searching for something more. A pattern, a flicker, a hint of the oracles. The silence is deafening, yet it fuels your curiosity. Historically, humanity's been here before. In 1609, Galileo turned his telescope to the heavens, revealing a universe far bigger than we imagined. Today, with radio telescopes and space probes, we're still looking, driven by the same urge to connect with something beyond ourselves. Here's another angle. The oracles might have left the galaxy entirely. If they mastered wormholes or faster-than-light travel, they could have ventured beyond our observable universe, leaving only faint echoes behind. You're imagining their departure, a fleet of ships vanishing into a cosmic rift, their legacy reduced to anomalies we haven't yet noticed. Or maybe they engineered their own extinction, choosing to merge with the universe rather than dominate it. The possibilities are endless, and each one makes the silence feel heavier. As you drift through this quiet cosmos, you feel a mix of wonder and frustration. The Fermi paradox isn't just a puzzle. It's a challenge to our place in the universe. If the oracles existed, their absence tells a story. Whether it's one of triumph, tragedy, or something we can't yet grasp, what happened to them, and what does it mean for us? That's where we're headed next. But first, let's hear from you. Why do you think the universe is so silent? Drop your thoughts in the comments, and let's keep unraveling this cosmic mystery together. You're standing on the ruins of an alien world, the remnants of towering structures stretching into a sky lit by a dying star. The air is thick with the weight of time, and you can almost hear the echoes of a civilization that once reshaped galaxies. The oracles. If they existed, their story didn't just end. It left a question mark that spans billions of years. Did they soar to unimaginable heights, transcending the physical universe? Or did they collapse under the weight of their own ambition? Let's explore the possible fates of the oracles and what their story might mean for humanity's future. Imagine the oracles at their peak. A civilization spanning countless star systems, their technology so advanced it blurs the line between science and magic. You're walking through one of their megacities, its spires pulsing with energy, powered by harnessed stars or even the fabric of space-time itself. But no empire lasts forever, not even one that tames the cosmos. The oracle hypothesis forces us to ask, what happened to them? Did they ascend to a higher plane of existence, leaving the physical world behind? Or did they fall, their wonders reduced to cosmic dust? You're sifting through the possibilities now, each one a piece of the puzzle. Let's start with the idea of transcendence. The oracles might have outgrown their physical forms, uploading their consciousness into a cosmic network or merging with the universe itself. Picture it. Their minds become a galaxy-wide web of thought, flowing through stars and nebula like a living internet. You're trying to sense them, feeling a faint hum in the void, as if their essence is woven into the cosmos. This idea, sometimes called the technological singularity, suggests a civilization could evolve beyond biology, becoming something we can't even comprehend. It's like they graduated from the universe, leaving us stuck in cosmic kindergarten. Here's a bit of cosmic humor. If the oracles transcended, they're probably laughing at us for still arguing over who gets the armrest on a spaceship. But seriously, transcendence isn't the only possibility. Another fate could be self-destruction. Advanced technology comes with big risks. Think black holes accidentally unleashed, or ecosystems collapsing under the strain of megastructures. You're standing on a shattered planet now, its surface scarred by what looks like the aftermath of a catastrophic experiment. Maybe the oracles pushed their tech too far, triggering a supernova or destabilizing their star system. It's a sobering thought. Even the mightiest can fall. Let's dive into a quirky detail. Some scientists speculate that a civilization could destroy itself by overusing resources, like mining entire planets to build Dyson spheres. Imagine the oracles stripping whole star systems bare, only to realize too late they'd broken their cosmic budget. There's even a theory that gamma-ray bursts, massive explosions we detect from distant galaxies, could be the remnants of alien experiments gone wrong. You're watching one of these bursts light up the sky, wondering if it's the oracle's final farewell. Now, let's spark some academic debate. What's more likely, ascension or annihilation? Some argue that any civilization advanced enough to span galaxies would have mastered sustainability, avoiding collapse. Others say the sheer scale of their tech would make failure inevitable, like a house of cards in a cosmic storm. You're weighing this now, wondering if the oracles found a way to balance their ambition, or if hubris got the better of them. Could their fate be a warning for us, or a roadmap to something greater? Picture another possibility. The oracles didn't vanish. They hid. Maybe they adopted a dark forest strategy, a theory suggesting civilizations stay silent to avoid hostile neighbors. You're imagining their worlds now, cloaked in stealth tech, invisible to our telescopes. Their cities might still hum with life, but they're shielded, like a cosmic bunker. Or perhaps they left our galaxy entirely, venturing into another dimension or beyond the observable universe. You're peering into a wormhole's shimmering edge, wondering if they stepped through and never looked back. Historically, humanity has seen empires rise and fall. The Roman Empire, at its height around 117 CE, spanned millions of square miles, yet it crumbled under internal strife and external pressures. If the oracles built a galactic empire, they might have faced similar challenges: social divides, resource wars, or even rebellion among their colonies. You're walking through their ruins, touching a fragment of alien metal, feeling the weight of a civilization that might have mirrored our own struggles, just on a grander scale. Let's paint the scene more vividly. You're on a planet that was once a hub of oracle activity. The ground is littered with crystalline shards, remnants of machines that once harnessed stellar energy. The sky above is a deep violet, streaked with the faint glow of a nearby nebula. You can smell the metallic tang of decayed technology, and the silence is heavy, broken only by the distant hum of a star. Did the oracles leave this world voluntarily, ascending to a higher plane? Or was it abandoned in a rush, fleeing some cosmic disaster? Each possibility feels like a story waiting to be told. Their fate, whatever it was, carries lessons for us. If they destroyed themselves, it's a reminder to tread carefully as we reach for the stars. If they transcended, it's a beacon of hope, suggesting we could one day join them. You're standing at a crossroads in the cosmos, feeling both small and inspired. The oracle's story isn't just about them, it's about us, about what we might become. What's the next chapter in this cosmic saga? That's where we're headed. But first, let's hear from you. What do you think happened to the oracles? Did they ascend, collapse, or something else? Drop your thoughts in the comments, and let's keep exploring their fate together. You're standing on Earth, but your eyes are fixed on the stars, a glittering tapestry that stretches across the night sky. The oracles, that ancient civilization we've been chasing, might be gone, ascended, extinct, or hidden in the cosmic shadows. But their story isn't over. It lives in you, in humanity's relentless curiosity, in our drive to explore the unknown. The Oracle hypothesis isn't just about them, it's about us, about what it means to be part of a universe that might have once echoed with alien voices. Let's wrap this journey by reflecting on our place in the cosmos and how we might carry forward the Oracle's legacy. Imagine yourself as the heir to a cosmic inheritance. The Oracles, if they existed, were the first to ask the big questions. What is the universe? Why are we here? You're holding their torch now, standing on a planet that's only just begun to reach for the stars. Every telescope you point at the sky, every probe you send into the void, is a step toward answering those same questions. The air around you feels charged with possibility, like the moment before a storm, as you realize humanity is part of a story that began billions of years ago. Let's zoom out. The universe is 13.8 billion years old, vast enough to hold countless worlds. Yet here you are, a tiny speck with a mind big enough to dream of infinity. The oracles might have built megastructures or transcended matter itself, but they started where you are now, looking up, wondering and daring to explore. You're walking through a modern observatory, its massive telescope humming as it scans distant galaxies. The cool metal and faint buzz of electronics ground you, but your thoughts are out there, chasing the same mysteries the oracles might have solved or left behind for you to unravel. Here's a cosmic chuckle. If the oracles could see us, they'd probably think our rockets are cute, like watching a kid ride a tricycle. But in all seriousness, humanity's progress is staggering. In just a century, we've gone from horse-drawn carriages to landing rovers on Mars. The Apollo 11 mission in 1969 put humans on the moon, a feat that would have seemed impossible to our ancestors. If the oracles followed a similar path, their first steps might have been humble, too. A single probe, a tentative signal, a dream of something greater. You're carrying that dream forward every time you ask what's out there. Now, let's talk about our role in this cosmic saga. The oracle's fate, whether they ascended, collapsed, or hid, offers a mirror for humanity. If they fell, it's a warning to avoid their mistakes, to balance ambition with wisdom. If they transcended, it's a challenge to aim higher, to imagine a future where we too could reshape the cosmos. You're picturing that future now. Cities on Mars, ships exploring distant stars, maybe even a Dyson sphere of our own. The universe isn't just a backdrop, it's a canvas, and you're holding the brush. Here's a quirky detail. Some scientists suggest we could one day seed the universe with life, spreading microbes to habitable planets. It's called directed panspermia, and it's something the oracles might have done, scattering the seeds of life across galaxies. Imagine finding a planet thriving with life they planted, its ecosystems a living monument to their legacy. You're walking its surface now, surrounded by alien flora that glows faintly under a double sun, wondering if this was their gift to the cosmos. Let's stir up some academic debate. Are we destined to follow the oracle's path, or will we forge a new one? Some argue that intelligence inevitably leads to self-destruction, pointing to our own challenges with climate change and conflict. Others believe we can learn from hypothetical predecessors, using technology to unite rather than divide. You're grappling with this now, wondering if humanity's curiosity will be our salvation or our downfall. Could we become the next oracles, leaving our own mark on the universe, or are we just a fleeting chapter in its story? Picture the scene more vividly. You're at a launch site, the ground trembling as a rocket roars into the sky, carrying a probe to explore a distant exoplanet. The air smells of fuel and ambition, and the crowd around you buzzes with excitement. This is humanity's answer to the silence of the cosmos, a refusal to stay quiet. a determination to find out what's out there. The oracles might have done the same, launching their first ships into a universe still glowing from its birth. You feel connected to them, not just as a dreamer, but as a doer, part of a species that's just beginning to write its cosmic story. Historically, humanity's quest for knowledge has defined us. The discovery of the heliocentric model by Copernicus in 1543 shifted our view of the universe, placing the sun, not Earth, at its center. Today, we're pushing further. With telescopes like the James Webb Space Telescope peering into the universe's infancy. You're looking through its lens now, seeing galaxies that formed when the oracles might have lived, feeling a kinship with those who came before. Their legacy, real or imagined, inspires you to keep searching, to keep asking. As you stand under the stars, you feel a profound connection to the cosmos. The oracle's story, whether fact or hypothesis, reminds you that you're part of something bigger, a universe that's been asking why since its first light. Your journey doesn't end here, it's just beginning. Every question you ask, every star you study, is a step toward inheriting their legacy. So, what's next? Keep exploring, keep wondering, and maybe one day you'll find their traces, or create your own. Let's hear from you. How will humanity carry forward the oracle's legacy? What's our next step in the cosmic journey? Drop your thoughts in the comments, and let's keep this story alive together.